Let's start back where we left off. So we have this object that's stationary, but it has collision. And I just want to make it rotating using only behavior script commands and no custom assembly code. Let's talk about a bit about behavior. So I will just reopen the behavior that we created last time using the default template. So you have this, which is pretty abstract for if you don't know what this is. So this is essentially a list of commands. Every line is a command. And how are these commands made? So there's a list here on hack64.net. Most commands are like 4 bytes long, and some of them are 8 byte long. 8 bytes. So generally the first byte decides what the command does, and then you have some parameters. You can also check this file from dcomp, which also has all of the commands. So some important ones are to know are this 08 and this 09. This makes the behavior loop. So essentially all that's before this is executed once at the object initialization. And all that's in between these two is run every frame. Also this 0c command runs a function every frame. So custom assembly essentially. And this is the address of the function. But we will talk about this in another video. For now, I will only use behavior commands to modify the behavior. So what we want to do is to change the rotation of our object. So essentially every object has a list of properties which are listed in this file. For example, there's the position, the velocity, that's the more important stuff. And we will, for this video, update the face angle yaw every frame. So let's check which command we would like to use for this. So this is a signed integer as provided by the S. F is for float and U is for unsigned integer. So we want to use a command that's for integers. So we have these two, add integer and set integer. We can look also at the documentation from hack64 for these. These are called offset by integer and set to integer here. You can see it starts with 0f. So let's just put this in our behavior script, like here, for example. I'm putting this inside the loop, so between the 08 and 09, so it's run every frame. Then we have the first argument, which is an address, and you can see here it's multiplied by 4 and added to 88. So we go back to this file, which lists the properties. It's written here also that 88 is the starting address, essentially, starting offset. So we will just do a bit of computation. So we take the offset here of our face angle yaw property. So d4, then we subtract 88, and we divide by 4. So that's 13 in hexadecimal. You need to take care to do this in hexadecimal, obviously. So we have our address, that's 13. And finally, we only have to put this argument, which is a 16-bit integer, which is added to it every frame. So I'll just use 0100. That's going to be added to the face angle every frame. So let's see what this does to our object. I'm just reloading the ROM. Okay, maybe I did not save. Yeah, okay. I just did not save. Right, so you can see it's rotating now. But there's something odd because Mario is not moving along with the box. So we will just fix this. That's just a bit of a quirk on how the game works. So there's also a second property that we need to modify, and it's this one, angle velocity yaw. So this one is used for visual rendering, and this one is used for displacing Mario essentially. So but this is a straight up angle, so we need to modify it every frame. However, this is a velocity, so we only need to set it once at the object initialization, and it will be applied to Mario every frame without us needing to explicitly change it. So, actually, I just noticed we can directly use this instead of doing the computation that we did earlier. So instead of subtracting 88 from this and dividing it by 4, we can just directly pick this. So this is the address we want to use. Again, this is a signed integer. So instead of using offset by integer, we'll just use set by integer. Again, the parameters are very similar. So the command ID is 10. So this time, instead of putting this in the loop, I would just put this in the initialization section. So 10, then the address is 24, and we will just use the same value as for previously. Otherwise, it would look a bit weird. Like visually, it would rotate faster than Mario is displaced. And this should be it. We just need to save and reload. And now Mario should be displaced properly. So we still have our object rotating, but now Mario actually rotates with the box. So, okay, so with these commands you can do some pretty basic stuff. But if you want to have like platforms moving back and forth and similar stuff, you probably need to have a custom assembly code. So I will try to talk a bit about these in the next video. Yeah, that's it. Thanks.